In this section here, we're going to be talking about linear inequalities in two variables. And really what we're going to be going over is how to graph linear inequalities. And the two variables are x and y. So let's take a look at an example here. And I'm going to attempt to draw an xy axis. Let's use a color. We'll use purple. I want to graph y is equal to 1. Now you should know how to graph y is equal to 1. So we're going to let this be 1 right here. And we're just going to draw a line that passes through 1. And so there it is, right? Of course, this line goes on forever in this direction and on forever in that direction there. Okay, so that's y is equal to 1. But what if I were to say y is greater than, or let's say equal to 1? We want to graph this. So what we're saying here is we're saying, listen, all values of y that are greater than 1 or equal to 1. Well, we know equal to 1 is a line, right? And so we have an infinite number of dots here that make up this line. But greater than 1, in other words, I can pick a value up here that has a y value that's greater than 1, or one here that has a y value that's greater than 1, or up here, or over here, or over here. Right, let's not leave off quadrant 2. Okay, so any one of these values over here satisfies this inequality. Okay, and of course we can actually pick a number. We can pick a point on the line because it says equal to. But what if I were to say y is only greater than 1? Well, if I were to say y is only greater than 1, then let's redraw our graph. Okay, and redraw our line. Greater than 1 means that we can choose any number up here that's above the line, but we cannot choose a number on the line. So we indicate that by just a dotted line. A dotted line, here's 1 on the y-axis. Right, this is just a dotted line. We can't pick a point on the line, but it satisfies everything, every point above the line. Y is greater than 1. All right. Let's take a look at x. So let's say that we wanted to graph. We'll give x a different color. We want to graph x is equal to 1. X is equal to 1. Well, that would just be a vertical line that passes through 1 on the x-axis. So there's the graph. We'll put a 1 here. There's the graph of x is equal to 1. Of course, it goes in that direction or in that direction. But what if I wanted to say, no, wait a minute, x is greater than 1? Well, or let's say greater than or equal to 1. In other words, I can choose any x value to make this true that's greater than or equal to 1. For example, we can pick a point here. Has some x value. It's greater than 1. It's to the right. Okay, so you can choose any x value you want. Now don't worry about the y, because all we're talking about is this inequality here. Or what if I said x was less than 1? Right? X is less than 1. Let's look at that graph. So x is less than 1. So we want to do this. So here's 1, we'll say, on the x-axis. And, oh, that says less than, not equal to. So less than. So that means we're going to use a dotted line because we cannot use it. Well, I can choose a point here. X is 0, and 0 is less than 1. Or a point here, 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 here. Any one of these points, okay, to the left of the dotted line satisfies this inequality. And so we may just indicate that with some kind of shading. You know, we'll say, okay, we'll pretend that this is all shaded. That looks like that hit the line, but it's not supposed to hit the line. Right, so we indicate this by some kind of shading here. Right, when we look at a graph of this guy right here. Right. So we're just going to focus on how to graph inequalities. That's what this section's. Alright, so let's get a little bit more complicated here. We can get just a little bit more complicated. What if I wanted to graph, let's say we wanted to graph x, we're in green. I guess we'll stay in green. X minus y is greater than or equal to 0. We wanted to graph this. Alright. So this is what we're going to do. Now, of course, you can solve for y in this problem, right? Solving for y, you'd end up having x is greater than or equal to y. Of course, you could flip this around and say y is less than or equal to x. You could just say y is equal to x, and of course, we know what this graph looks like. Y is equal to x is going to be, right, it's going to be a line that looks like about like this, right? That's the graph of y is equal to x. Okay, but sometimes, doing this takes out a lot of time. So the best way to do this is probably this way right now. Okay, I just, I'm thinking I better not get too complicated too fast here. But you can look at the x-intercepts and the y-intercepts. That's where the graph crosses the x-axis and the y-axis. And then you can look at the slope of the line by just looking at these coefficients here and plugging things like 0 in for x. What is y going to be? You see, plugging 0 in for y, what would x be? So that would be finding the x and y intercept. Alright, well, this guy right here is in a standard form. That means that x is over here, y is here, and there's a positive coefficient in front of the x. Now, we want to get these in standard form. Okay, they may not be initially written in standard form, but we want to get them in standard form because that's going to help us to determine which side of this line needs to be shaded, the left side or the right side, or above it or below it, however you want to look at that. But think of this guy right here as being an arrow. So I'm going to put a dot here on the line. Notice that my arrow is pointing to the right, and that means that this side is going to be shaded. In other words, everything on this side of the line, should have probably done that in a different color, everything on this side of the line is our solution to our inequality up here. If I were to pick a point, let's say right here, okay, we're going to pick a point on the x-axis and we'll call that point 2, 0. If I were to plug that in here, 2 minus 0 is 2, and 2 is greater than or equal to 0. Okay, so everything on this side of the line is our solution to our inequality. Alright, simple enough. I think we're due for a new one. Let's erase. Alright. So we're going to draw up an XY axis. And let me just come up with one. Let's say we have 2x plus y is greater than or equal to 0, and we want to sketch the graph. So the first thing I'm going to do is sketch the line. Where is the line located? That's the deal. So we're going to find our x-intercept, and then we're going to find our y-intercept. So remember the x-intercept, that's where it crosses the x-axis. Okay, that's when y is 0. So we want to plug, let me just rewrite this. We want to plug a 0 in for y here, and then we want to solve for x. Well, it turns out that x is, it looks to me like x is equal to 0. When y is 0, x is 0. That's what it looks like. Okay, so we're looking at crossing through the origin right here. So our x-intercept is at 0. Okay, we should actually say that point. We should call this a point. So this would be 0, 0. Alright, now what we want to do is find the y-intercept point. So that's when y is 0, and we want to know what is x. Well, we plug 0 in for y, or what's going on here? The y-intercept point, that's when x is 0, sorry. And we want to know what y is. Well, we plug 0 in for, remember the y-intercept is where it crosses the y-axis, and the x-intercept is where it crosses the x-axis. So we plug 0 in for x. So let's just do that. Plugging 0 in here, we get 0 plus y is greater than or equal to 0. So it looks like that the y-intercept is going to be y is equal to 0. Now, we're not really looking at the greater than sign here. We're just looking at the equal sign, okay? So y is greater than 0. Now, y is equal to 0. So that it said 0, 0. All right. Well, we know that the graph crosses right here at the origin, okay? And it's going to end up having a slope of -2. Now that's if you were to solve for x in this problem, solve for y in this problem, which would end up being y is equal to -2x. So you would just take this over to this side. And remember that this guy right here is the slope of the line. And it's negative. So that means that the graph is going downward in this direction right here. Okay, it's going downward. The slope is negative, and therefore the line is decreasing. We talked about graphing in a previous section. I can't remember, equations of lines, or one of those sections, when we went to graph linear equations. Okay, well, this is in standard form because we have our x's written here, y's written here, constants written over here, and this is a positive number. Now I said there was a shortcut to that, and that is, you notice this guy right here, we put the cursor here on the line, and our inequality is pointing to the right. Pretend that's the head of an arrow. So that means that everything on this side of the line is shaded. Okay, and let's just do that in a different color. So everything on this side of the line is our solution to our inequality here. And let's just check that. Let's pick a point like 1, 1. So we're going to pick the point 1, 1 up here, plug it in. So we have 2 times 1 is 2, plus 1 is 3, and 3 is greater than or equal to 0. We have a solid line because we're including the equals here. Okay, if we weren't including the equal and this was just greater than 0, then we would use a dotted line indicating that we cannot use a point off that line. Alright, so there's our solution. Okay, so let's look at another one. Hopefully maybe you're catching on to this. Let's hope. Alright. So let's do negative x minus y is less than or equal to 5, let's say. We want to graph this. Well, the first thing that we notice is that it's not in standard form. We need to get it in this standard form to where this is a positive number here. And by doing that, we're going to multiply -1 by the whole thing. In other words, -1 times negative x is x. -1 times negative y is a positive y. And if I multiply a negative all the way across, we got to flip the inequality. Okay, and then that makes that a -5. So we want to find our x-intercept points and our y-intercept point. We want to find both these points, and then we can draw a line through both points. So to find the x-intercept point, we're going to remember that's where it crosses the x-axis, so we're going to let y be 0. Okay, we're going to let y be 0, so this is going to be x plus 0 is greater than or equal to -5. But this ends up becoming, now just kind of forget about the inequality here, pretend this is an equal sign. So x is -5. Okay, so our x-intercept point, we have x is going to be equal to -5 when y is 0. All right, we plug 0 in here for y, and x is -5. So let me go ahead and write that point in. So -5, 0. And that's we're going to say that that'll be right here. How's that? So we have it in our picture. Okay. Alright, now let's find where the graph crosses the y-axis. And so that's going to be the y-intercept, and we want to find that y-intercept point. Okay, so I'm going to rewrite this. This is x plus y greater than or equal to -5. Alright, where it crosses the y-axis, this is when x is 0. And we want to know what is y going to be. And it looks like y is -5 also. So we're going to put -5 right down here. Okay. So we're looking at a line that's passing through both of these points right here. Okay. And it's in standard form. We want to pick a point, just pick somewhere on the line right here. Now, which way is it going to be shaded? This direction or this direction? Well, all we got to do is look at this guy right here. Okay, and it's pointing to the right. So it's pointing over here. So that means that every single point on this side of the line, all right, is going to make this true. So let's just pick a point, and of course an easy one to pick is the origin. If I plugged 0 and 0 into this, so 0 plus 0, is that greater than or equal to -5? Yes, 0 is greater than or equal to -5. So it's like if you just if you chose a point and you plugged it in over here, if it makes it true, then you know that every single point on this side of the line is going to also make this true. But I like to look at it this way, where I put my cursor on it. Which way do I go? Over here, over there, right? Depending on what this looks like. Now, the key is that this must be in a standard form, which I'm calling this to be a positive coefficient right here. It doesn't matter if this is negative or positive. It doesn't matter. This is what matters. If this is negative or positive, we want it to always be positive. You see, it was negative up here, but in order to get rid of this negative, we just multiplied through by negative all the way across. But when we do that, we have to flip this inequality here. Okay. So anyway, it looks like that everything on this side of the line is going to be, all the points on this side of the line, including this line, right, including a point on the line, will make this true. And we have to choose every point on the line because, look, we're including this. This is greater than or equal to. This is the equal to sign, which means we include that. Okay? So it's real simple. We make sure we get it in standard form. We find our x-intercept or y-intercept point, right? Just kind of pick a point here and then draw a line through the 2 points, and then we determine which side of this line needs to be shaded, left or right, or however you want to look at this, up or down. Okay, I'm looking at it left to right because of this guy right here looks like the head of an arrow and it's pointing to the right, which means everything to this side of the line needs to be shaded. Okay, well, let's look at a couple more. Now the question is, when will you ever see this again? Well, if you ever take finite math in college, you'll be doing lots of this. And of course, if you take college algebra, you might be doing this also. Okay, let's do this. How about -3x plus y is less than, let's say, 4. Okay, so step 1, let's get this in standard form before we do anything. That means we multiply through by a negative all the way across. So I'll just bring this down right here. So we want to make sure that we multiply this by a negative to both sides, -1 to both sides, right? So it's going to make that a 3x minus y is greater than So we multiply this -1 across, and this becomes, so we flip the sign, and then this becomes -4. So we have it now in the standard form. Let's find the x-intercept point, and then we'll find the y-intercept point. So remember, the x-intercept points where it crosses the x-axis, and this is when y is 0. So we're going to let y be 0. So 3x minus 0, right, is greater than -4. So we solve for x in this problem, and we end up with not a nice number. Now we could just write an equal sign right here, if we wanted to, because we're just trying to find where it crosses the x-axis. So I'm just going to do that. So don't be confused. I'm just writing an equal sign here, okay? So this becomes -4/3. Right, we multiply both sides by 1/3, and we get -4/3. So that's we'll say that's right here, -4/3. So we know that it crosses the x-axis right here. Okay, so now let's find where it crosses the y-axis. That's when x is 0. So this is going to be the y-intercept. Of course, I'm not writing the point here, but the point is going to be -4/3, 0. Okay, that's your point right here, -4/3, 0. The y-intercept, so that's when x is 0, so 3 times 0 minus y, and you don't mind, I'm just going to write an equal sign here, so don't get confused. We're just trying to find where it crosses the y-axis, alright? So we end up with negative y is equal to -4, but we multiply both sides by -1, and so we get y is equal to 4. So the point here is going to be 0, 4. So 0, 4, and we'll say that this up here is at 4, and so this is 0, 4 right up here. So we're looking at what are we doing here? We're looking at a line that passes through these 2 points, so let's go ahead and draw that line, and I'll just draw it green. How's that? So we're going to attempt to cross this. Okay, so here's our line. I made a mistake. Look out, there's not an equal sign right here. You notice this? No equal. So this should be a dotted line right here. This should be a dotted line. Okay, so let's go back and draw a dotted line. Whoops, I didn't mean to do that. It's okay. Alright, so we have a dotted line here, which means that we don't include, right? We don't include the line itself. Alright. Okay, question is now, which side of this dotted line is shaded? Well, we look at our standard form, right? And we notice our inequality is pointing to the right. So I just pick a point here, and we're pointing to the right. Put an arrow over here, so pointing to the right. So that means that every single point to the right of the dotted line, every single ordered pair, right, is a solution to our inequality right here. And we can always choose 0, 0 to test this. Right, we plug 0 in for x, we get 3 times 0, 0, minus 0, and therefore 0 is greater than -4. Okay, so I always choose the origin because it's a whole lot easier to choose. Right. So we shade everything to the right of our dotted line. Okay. Alright, let's look at something a little different, and that is what happens if we were to graph two shaded regions. Alright. Alright. I should say something here real quick. I don't think I'll have any application problems worked out for you applying this stuff in the real world, but there is a section in finite math that eventually I'll get around to, and I've worked lots of real-world application problems that involve these linear inequalities, and it happens to be under linear programming. It's called linear programming. I've worked several problems, did some models for some farmers in Arkansas how to maximize their crops and so forth. But anyway, okay. Well, let's talk about something a little bit different. We're going to add to this concept we've been talking about. And we've been graphing, or I should say finding the solution set to one inequality at a time. But what if I had a couple inequalities, like for example x is greater than or equal to 1 and y is greater than or equal to 1, and we wanted to graph these and find the solution set that satisfies both of these simultaneously. So remember, we know how to graph x is greater than or equal to 1. We'll use that as a different color. So here's 1. Remember, x is greater than or equal to 1. X is equal to 1 is just a vertical line passing through, and of course it's not a dotted line, it's a solid line because we include 1. And then y, we'll use that as a different color. Y is greater than 1, so let's graph that. Now, I guess what I left off on the y, x is greater than or equal to 1. So remember, that's everything that's shaded to the right of the green line. Okay? And y is greater than or equal to 1. That's everything that is shaded above this line. And so what we're concerned about is the intersection of both of these shadings. The intersection, what do they both have in common? Well, both the red and the green lie in quadrant 1 here, as you can see. Both red and green lie in quadrant 1. So this over here, of course, if I knew what green and red, what is that, orange? That's like an orange color, isn't it? Not green and red. Green and red. I don't know, brown, something like that. But anyway, I'll just do like this. So we're talking about this quadrant right here. This quadrant satisfies both of these simultaneously. In other words, if I picked a point over here in this quadrant like 5, 5, and I plug it in, well, 5 for x is greater than 1, and the 5 for the y is greater than 1. Okay, so you know how to find where two regions overlap. Okay, if you know how to graph, find the solution for one line, then you know how to do it for two, because we just look at where they overlap. Alright, so let's look at, I'm not going to write the equations up, we'll just draw some pictures. So let's say that we happen to graph this guy, and let's say that everything was shaded to the left of it. Okay, and then we graphed another equation. Let's say that we graphed another equation. Let's say it went down like this, and everything was shaded underneath it. Alright, so now we want to find out what's a solution set that satisfies both of these. Well, it's where these shadings overlap, and that's going to end up being, and you know what, I'm going to make this a different color. That's going to end up being all of this stuff. Okay, this is the solution set. And of course, everything going, to infinity off in that direction, unless specified. But as you can see, this is going to be our solution. This would be the area. It's where the two shadings overlap. Okay, so you just graph them simultaneously, and they'll be written, like this. So we'd have one equation here, and then another equation here, and then, hey, we could actually even have three equations, right? Just graph them all and find out where their shadings all overlap, and that's going to be your solution set. Alright, that means that you can pick a point somewhere in here and you can plug it into all three of them, and all three will be true. It'll be true for all three. It'll be a solution for all three of these simultaneously. So that pretty much sums up linear inequalities in two variables.